Good morning. This is the subject Hydrology CN4407, and I am Blessy Bandivas, the first reporter for the topic Groundwater Storage, Hydraulic of Flow, Groundwater. So, as you can see on the screen, this is the hydrologic cycle. So, it was already discussed by Sir Benante, but I will just review it. We first discussed this before we discuss the groundwater because we should first know how or what are the process that the water goes through before it end up in the groundwater. So hydrologic cycle, evaporation. Evaporation occurs when the physical state of water is changed from liquid state to gaseous state. Let's go back to the first slide. So as you can see in the screen, there are three types of evaporation. Evaporation, transpiration, and evapotranspiration. So the evaporation is the forming of water to gas na nag-source siya gikan sa body of water. Then the transpiration is the evaporated water from the plants, trees, and the ground. Then the evapotranspiration is the sum up of the transpiration and evaporation. The next is condensation. Condensation is the process by which water vapor changes its physical state from a vapor, most commonly to liquid. So from evaporation, the water vapor will form into a clouds. Due to the lower temperature of the atmosphere, it will return to its liquid state. Then if the clouds get heavy, it will form into snow or rain. The rain or the snow is what we call the precipitation. So what is the precipitation? Precipitation is a process that occurs when any of all forms of water particle fall from the atmosphere and reaches to the ground. When any type of water like rain, snow, sleet, or hail hit the surface of the ground, it is called precipitation. Next is interception. Interception is the process of interrupting the movement of water in the chain of transportation events leading to streams. The interception can take place by vegetal cover or depression storage in puddles and inland forms such as rills and furrows. So in short, what we call interception is the water that's stored on the surface of the ground that didn't successfully transported from the ground to the body of water. Eventually, it will be evaporated din naman or it will be absorbed by the soil. Next is infiltration. Infiltration is a physical process involving movement of water through the boundary area where the atmosphere interfaces with soil. So infiltration is the process of filtrating of the water by the ground. Then it is the first process before the percolation occur. Percolation is the movement of water through the soil and its layer by gravity and capillary forces. So in short, percolation is the process of absorbing the water from the surface to the ground. Then the ground will filtrate it. The water that filtrated will go underground and it will be stocked in the water bed. Next is transpiration. Okay, transpiration is I already discussed the transpiration kanina. Transpiration. Transpiration is the biological process that occurs mostly in the day. So we already know that it is a kind of evaporation. It is the water vapor that came from the plants and the ground. So runoff is flow from a drainage basin or watershed that appears in the surface stream. So runoff is just the opposite of percolation. Runoff is the water that wasn't able to be absorbed in the ground. So it will flow from the higher surface to the body of water. To sum it up, the first process that the water goes through is the evaporation. From evaporation, it will condensate, then precipitate. Then from precipitation, the water that will be absorbed by the ground will be infiltrated. So from precipitation, the water that will be absorbed by the ground will be filtrated, then it will percolate until it reaches the underground storage. Storage. There are three basic locations of water storage that occur in the planetary water cycle. Water is stored in the atmosphere, water is stored in the surface of the earth, and the water stored in the ground. Water stored in the atmosphere can be moved relatively quickly from one part of the planet to another part of the planet. So this is the water that stuck in the atmosphere. Then it is in the form of snow, rain, or clouds. The next is the type of storage that occurs in the land surface and underground largely depend on the geologic features related to the types of soil and the types of rock presented in the storage location. Depending on what kind of soil you have on allocation, it will either stored underground or be stored on the surface of the ground. Storage occur as a surface storage in the ocean, lakes, reservoir, and glaciers. Underground storage occur in soil, in the aquifers, and the crevices of rock formation. So the water that's stored on the surface of the land is what we call the water formations, like lakes, rivers, sea, or any kind of body of water. And underground, the water can be stored on the soil or in the waterbed, in aquifers, and such. Next, what is groundwater? Groundwater is the water that exists underground in saturated zones beneath the land surface. The upper surface of the saturated zone is called the water table. Groundwater is the water that filtrated by the soil until it goes deeper and deeper until it ends up on the groundwater storage. Groundwater represents about 30% of the world's fresh water. From the other 70%, nearly 69% is captured in the ice caps and mountains, snows, glaciers, and merely 1% is found on the rivers, lakes. Groundwater counts in average of one-third of the fresh water consumed by humans, but at some parts of the world, this percentage can reach up to 100%. It is stated that 30% of the fresh water came from the groundwater. Then the other 69% is stored as a form of ice. Then 1% of the fresh water is from the river and lakes. So what is groundwater storage? Groundwater storage is the difference between the charge and discharge over the time frame that these processes occur, ranging from days to thousands of years. Changes to both groundwater and surface water levels may ultimately alter the interaction between the groundwater and surface water, and the interaction between the natural and societal water supply and demand. In short, the groundwater and the surface water correlate with each other. That will ultimately affect our water supplies and demand. Groundwater storage is affected by intrinsic properties of the aquifer. Aquifer is the storage capacity, transmission capacity, and aquifer geometry, controlled by its size and type. So, ang size of type po di ay isa ka aquifer will define what groundwater storage we have on a certain area. So, let's proceed on the groundwater flow and storage. Groundwater is the fresh water from rain or melted ice and snow that soaks into the soil, and it is stored in the tiny spaces or pores between rocks and particles of soil. So this water is from the surface that successfully filtrated and absorbed by the ground, and it remains in underground. Bank storage is one way that the groundwater may be stored. During the spring runoff, the level of lakes, ponds, streams, and rivers rise due to the precipitation or snow melt, saturating the banks of the water body. This stored groundwater then slowly flows back into the water body and augmentates some really low flows. So bank storage is one way of storing water underground. It is the water from the runoff that goes to the body of water, and then it will be stored on the banks. But eventually, it will come back to the body of water. Subsurface water. Water in soil mantle is called subsurface water. Water beneath the surface can essentially be divided into zones. The unsaturated zone, also known as the zone of aeration, which includes soil water zone, and the zone of saturation, which includes the groundwater. Sometimes, especially during the times of high rainfall, these pore spaces are filled with water. Let's first discuss about the aeration zone. It has three sub-zones: the soil water zone, intermediate zone, and capillary fringe. Soil water is held in the pore space between particles of soil. Soil water is the water that immediately available to plants. This water can be removed by air drying or by plant absorption, but cannot be removed by gravity. Plants extract this water through their roots until the soil capillary force is equal to the extract force of the plant root. So what is the capillary force? The force holding the water to the particle. At this point, the plant cannot pull the water from the plant rooting zone, and it wilts, called the wilting point. The amount of water held in the soil after excess water has drained is called the filled capacity of the soil. The next zone is the intermediate zone. This is the layer that is available next to the soil water zone. It lies in between the soil water zone and the capillary zone. So it is the water stored between the capillary zone and the soil water. So capillary zone. The capillary fringe is the subsurface layer in which the groundwater seeps up from a water table by capillary action to fill the pores. Pores at the base of the capillary fringe are filled with water due to the tension saturation. The saturated portion of the capillary fringe is less than total capillary rise because of the presence of a mix in pore size. If the pore size is small and relatively uniform, it is possible that the soil can be completely saturated with water for several feet above the water table. Alternately, the saturated portion will extend only a few inches above the water table when the pore size is large. Capillary fringe is the one responsible of absorbing water from the actual water table, the underground water. So depending on the pore size of the capillary fringe, it will affect how much water it will absorb from the actual water bed. So if it is smaller and uniform, it will absorb water several feet above the water table. But if it is large, it will only absorb or to the extent of few inches above the water table.